Hello everyone, I'm Norman Wildberger, and today we're going to be looking at new kind of ideas towards staff notation in music. So this is a subject that's interested a lot of people for a long while. For example, in the early part of the 20th century, Arnold Schoenberg, the famous 12-tone composer, advocated a system to enable him to work more smoothly in his 12-tone system, where the usual staff with 5 is now replaced with 6, but we're still going from a C here, which is in the same relative position as usual, up to this one here now. So going a total of 1, 2, 3 lines up. But still all 12 tones in this range. And the way he does that is he creates 3 note positions between any 2 lines. So not actually on the lines, but between the lines, sort of on the bottom line, in the middle, and below the top line, and further little diagonal strokes to help orient you as to which one of these you're looking at. So this actually has some similarities with the proposal that I'm going to make, okay? Because I also want to have a system where we get all 12 tones sort of equally spaced in a nice way without having sharps and flats, which confuses the situation. Okay, but since then there have been a lot of other attempts at convincing people that we should change our musical notation. But of course there's a lot of tradition to work against. But a notable example of that is one due to Cornelis Pot, a Dutch fellow who introduced what's called clavar notation. And it's quite innovative because the notes that you're playing at a given time, instead of being sort of vertical as they are with most systems, are actually horizontal. And his idea is to represent the actual physical locations on a piano with a horizontal strip of notes. So that even a beginner piano player could sort of read down the page and see where they should put their fingers, as you go down. So this is quite interesting. That was in the 1930s. But there have been lots of others. For example, George Skapsky introduced what's called Pannone notation in the 1950s. J. Bayreuther introduced a system where black and white notes were both used in 1959, and that's actually quite important for us because we're going to be doing that too. Okay, so we're going to be following him. Actually, in his footsteps, also Jay Brownstein, actually more recently, introduced what's called chromatic lyre notation, and also used black and white notes prominently. And here is an example of something in his notation, actually the first prelude in Bach's Well-Tempered Clavier in C major, in this chromatic lyre notation. Now, to access a lot more ideas in this direction, there is a book by Thomas Reid, published in 1997, called Directory of Music Notation Proposals. So it's actually quite a large history of these things, and it really points to the fact that our current system has a lot of weaknesses, and many people are looking for ways of improving that, to make it easier for people to access music, essentially, and also for composers and players to not be inconvenienced by the somewhat ad hoc nature of our current system, which is largely piano-based. Okay, so a very quick review of the difficulties, or some of the difficulties, with our standard staff notation. Here's the piano octave from C to C. Here are the representations of the white notes, but unfortunately the black notes are much more complicated. So there's a basic sort of asymmetry between the white notes and the black notes. Furthermore, that also manifests itself in the sense that the interval sequence here is not uniform. So there's some intervals between white notes which are just 1 steps, while the others are 2 steps. And that has the consequence that, for example, to go from the E to the F is actually, even though it's just going up 1 step, it looks a lot like the step from G to A. It's actually not, quite different. This is a 2-step and this is a 1-step. So there are actually 3 such places, from E to F and from B to C, and then also from E to F again. 3 places just on this treble clef. So that creates problems for translation or transposition. It means that you can't just look at a configuration of notes, say like this triad here in red, and immediately see what kind of a chord it is. In fact, this chord here with E, G, and B is a minor triad or minor chord, while this one here, which has the same kind of shape from G to B to D, is a major triad or major chord. Well, this one here, which again has the same kind of form, from B to D to F, that's a diminished chord or triad. So, you know, there's a complete disconnect in terms of moving things up and down and things being the same. So the natural uniformity that we have in a 12-tone system with our equal temperament or well-tempered approach, that natural uniformity of translation is lost in our notational system. And of course, that's even accented more when we also think about the bass clef, which is yet another system where, again, the various idiosyncrasies are in different places. So you have to learn the idiosyncrasies for the treble clef and for the bass clef separately. So we want to try to think of a better way. So my new proposal is that we should step away from the piano orientation. Rather, we want to move to a clock view of things where we have our 12 tones and where we're flexible as to the interpretation of the zero. So we may be playing different instruments, guitar, saxophone, trumpet, whatever. They naturally are sort of based on different pitches than a piano. So it's good to be flexible. So for us, zero is just some fixed note, but we're not saying which one it is. And we're going to have essentially one staff. Everything is describable just in terms of the one staff. You can think about this as the treble clef or the bass clef. So it turns out in this system that those two things look exactly the same. Okay? The treble clef and the bass clef, there's going to be two of them, but they're going to look exactly the same, and the notes are going to be exactly the same, just a couple of octaves down. Okay, so what are we going to do? So we want to represent the 12 tones, say starting with this one here. This is a black note in the usual position of C, if this was a usual treble clef. And that's not C for us, that's note 0, whatever 0 is. And then the subsequent notes. One is the same level, okay, but it's a white note. So we go from black note to white note. It's going up one step, we agree. And then we'll say the next level is going from this line to the next space. So that would be that one there. We get a black note in that space. That's going to be note 2. And then changing it to a white one, that's 3. And then we just keep on repeating that. We just go up a level. So from this space to this line, then from this line to this space to this line, etc. And at each stage there are two notes. First a black one and then a white one. So it's a little bit simpler than Schoenberg's notation, for example, because there's no sort of different positions. There's just one note position in the space, just like there is in the usual system that we currently use. So it looks a lot like an ordinary system, except that the notes are black and white. That's a big departure. Let me say a little bit about that. So the distinction between black and white notes on a page is a very noticeable one. If you look at a page of music from a distance, you may have trouble saying exactly, whether that note is on the line or a space, but you're not going to be confused as to whether it's a black note or a white note. That's very visible. So it makes sense for us to use that highly clear visual signal of the color of the note in a strong way. Currently, our system uses that particular color difference only more or less to distinguish between a quarter note and a half note. So it's reserved for saying something about the length or the extent or the duration of a note. That's a relatively minor kind of application of this really powerful idea. So I want to bring this idea center stage, and I'm following again Bayreuther and Braunstein's ideas too. This is exactly the same thinking that they would have had. Okay, so we're going up, okay, by one step, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or 0. That's our 12-tone chromatic scale, and we've started on this line here just below the regular staff, and we've gotten up to this middle line here. So we've gone basically from here to here, so that's an octave for us. And that's very easy to remember because we're just going up 3 lines. Or if we started on a space, we're going up 3 spaces. That's an octave. All of these are octaves. So the entire pattern is repeated. So this note here is the same as this one here. So after we get to this note, if we want to keep on going up, we're going to go this way. Okay, that's 0 again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then we get to like a high high C or a high 0. Okay, so overall we've spanned 2 octaves from this note, just one below the staff, to this note, just one line above the staff. And we have all the notes, 12 tones plus 12 tones in this system, and we have no sharps and flats, importantly. Okay, so it's quite interesting, and you can see some interesting patterns. So for example, the black notes are all even numbers. So they correspond to a uniform 2 scale that I've showed you before. Remember, there were 2 uniform 2-step scales. C, D, E, F sharp, G sharp, A sharp, B was one of them, and then D flat, E flat, F, G, A, B, D flat again was the other one. So those 2 things are represented by the black notes and the white notes respectively. Okay, so the uniform scales are in there. And if we go up by 4, well, then we're going from a line to the next line. So that's also a very important sort of step, from here to here. That's like a major third. An interval, a 4-step is a major third. So the separation between these lines here is, in each case, a major third interval. That's actually quite pleasant, because a major third is actually a very nice interval, and it's actually a very common interval. Arguably, it's maybe the most important interval, arguably, okay? So it's pleasant for us to have the separation between one line and the next line being a 4-step, or similarly between a space and the next space above, that's also a 4-step. So from here to here is a 4-step. And the nature of these even intervals, like a 4-step or a 6-step, let's say look at a 6-step, okay? So we're going from here to here, that's a 6-step. So we're, in terms of levels, we're going sort of up 1, 2, 3 level, and the colors are the same. So similarly, a 6-step from this one here, going up 3 levels, 1, 2, 3, the color is the same, so it's that to that. So the even steps are really easy to visualize, and they're the same, essentially, whether we're starting on a black note or a white note. However, the odd step intervals are a little bit more complicated. So for example, just the one step from 0 to 1, you see what that looks like. It just looks like from a black note to the white note on the same level. That's a 1-step. However, there's another kind of 1-step, going from a white note to a black note. Now we have to go up a level. Okay, so a white note at that level to the black note on the next level. That's also 1-step. So there are these 2 different kinds of 1-steps, depending on whether you're starting on a black note, like from here to here, or on a white note from here to here. But once you've understood those, well, then the pattern is the same all throughout. Okay, so yes, there's a little bit of work in looking at these various intervals and sort of seeing, well, what does a 5-step, so it's like perfect fourth. From here to here, that's one kind of 5-step, but also from here to here is a different kind of 5-step. So you have to sort of stare at it and get familiar with, this is a 5-step, and that's also a 5-step. But once you've understood that, well, then it's the same thing here. Like go from here to here, that's a 5-step. Go from here to here, it's a 5-step. It's the same pattern everywhere. Okay, so the odd intervals, the odd step intervals are a little bit more complicated, require a bit more work to get your head around. But it's all, I would say, a lot simpler than our current system. A lot simpler because of this built-in uniformity and the fact that what I'm saying here applies equally to the bass clef and to the treble clef. So if there was a bass clef down here, there would also be 2 octaves from the 0 down here to the 0 to this 0 here, and then another 2 octaves from this 0 to that 0. So 4 octaves altogether, spanned in a nice way by the bass clef and the treble clef together. So a little bit more experience getting our heads around this new proposed system, which we might call sort of like a parity system, because the black and the white stories are pretty well on the same footing here. So here are major chords. So starting on any tone, there's a major chord. It's like a 4-3 chord, consisting of a 4-step followed by a 3-step. And it's important for students of mathematics to know what the major chords on any tone are. And here's sort of the classical version. There's the major chord or triad on C, on D flat, D, E flat, I don't know why I mixed these up, E, and then F sharp, and then G. and I'll do the next on a separate slide. So you can see that in the usual system, it's not clear what the pattern is at all. You know, some serious memorization has to be put in to get your head around where all these things are. Here, in distinct contrast, the situation is pretty simple. There are basically only two shapes that you have to remember, and then you just repeat them. You just translate them in the most obvious fashion. So starting with note 0, so if you like, think of 0 as being C, then this is the same as this. So there's note 0, there's note 4, okay? And there is note 7. Because if we were counting, so there'd be 0, 1, the white note, and then the space, 2, 3, and then this is 4, and then 5, and then the space black, and then the space white, so that's 7. So that's like 0, 4, 7 note in our system. Now, if we start on note 1 instead, it's a little bit different. The thing has a little bit different shape. The 4 step is still from this line to this line. 4 steps are always that way. But now the 3 step, which is an odd interval step, okay, has a different shape than this one. You have to go up a little bit further. So you have to go from this one to this one, because if we were counting, the next note would be the black note, this one here, okay? And then the next one after that would be this one. And then the next one after that would be this one. So from here, it's 1, 2, 3 to get to that one. Okay, so there's a 4 step here and a 3 step here. And it looks more like a regular triad like this. But there's 2 white notes here and a black note. Over here, there were 2 black notes and a white note. So remembering the colors is an important part of remembering this overall shape. But once you've gotten your head around these 2 examples of a major chord, well, then the other ones are pretty simple. You just translate them up. So a chord built on 2, it's the same pattern. We start with note 2, we do a 4 step to the corresponding next space, and then we do one of these sort of adjacent white notes. And then 3 looks just like this one, except everything is sort of up 1 level from this line to this space, and then this space, and then this space. 2 white ones followed by a black one. And then it just carries on. There's number 4, 5, 6, 7, etc. in both bass and treble clefs. So you can see that the possibilities for understanding chords is much simpler because there's a uniformity here, a natural uniformity, which is reflecting the uniformity that we've built into our musical system by adopting this well-tempered 12-tone system, where all the notes are equally spaced as far as frequency ratios go. So just for completeness, here's sort of the other ones. So again, 7 is where we ended up with the last slide. And then, so bottom here is note 7, and then going up note 8, note 9, 10, 11, and then back to 0. Okay, and here are the major triads built on all of those, the same kind of pattern. In terms of stems, so stem up, typically if the notes are sort of in the lower half of the staff, then the stems go up, and if they're in the upper half, then the stems go down. But it's not an absolute rule. But so, you know, this is the same kind of picture. It's basically these 2 shapes repeated. 2 white notes and then a black note, all sort of equally spaced, or 2 black notes and then a closer white note, like here, here, and here. And in contrast, here are the other triads in the usual system. There's G, and then there's A flat and A and B flat and B and C and D flat and D. And you can see, you know, there's, you know, you sort of have to memorize these. It's hard to have a really sort of good systematic understanding of these. And yeah, there's just a world of difference, in my view, between trying to understand music and harmony from this kind of point of view, rather than with this one, which is much more logical and sensible, and accords more with the actual music, you know, the mathematical symmetry that we have naturally in our music, because it's a translationally invariant system. So the final thing to talk about is the second issue, having to do with note length or duration or extent. And remember that we've taken the white-black distinction, which was the difference between a quarter note and a half note, and we've utilized that in a different fashion. So we're obliged to find some other way of distinguishing quarter notes with half notes. Now, there's all kinds of possible more fancy systems that we could use here, but I think the simplest thing is pretty well to use the existing system, basically starting with a quarter note as sort of the basic thing, just a single note head with a stem either going up to the right or down to the left. But now, of course, that note head could be a black note or a white note. Both are allowed, so that's different from previously. And then to get these other ones, we just put little tails. Each time we put a tail, we're dividing the duration by 2. We're making it half as long. So this would ordinarily be called an eighth note, but I prefer to actually have somewhat more sensible names for these things. So this note here, the quarter note, it's really unfortunate terminology. In 95% of all cases, the quarter note is getting the beat. Okay, not in all cases, but most cases. The quarter note is getting the beat, so it's really the note length which corresponds to a beat. So it's much more accurate and descriptive, and I think useful to call it a one-beat note. So let's do that, all right? So if that's a one-beat note, well, that's going to be a half-beat note, and that's going to be a quarter-beat note, and that's going to be a 1/8 beat note, and those are a little bit easier to deal with than 1/8 and 16th and 30-seconds. Okay, but what about the step from here to here, from what's usually called a quarter note to a half note, what we're going to call a one-beat note to a two-beat note? So we have to make up something here, because we can't just use the white. We've already used the black to white note already. So what I propose is that somewhat in line with this, that we use something like this where we take, say, a black note there, and we have 2 little stems. So maybe one going up to the right and one going down to the left. A little bit shorter so the thing doesn't take up quite so much room, so maybe half the size. But there are 2 stems here. Okay, there's 1 stem here, there's 2 stems here, maybe suggesting that this thing is twice as long. Okay, and whether the 2 stems go in this fashion, or maybe they both go down, or maybe they both go up, well, something in this direction, all right? And then the 4-beat or whole note, well, we could do that by actually using a symbol which is already around. I think it's called a breve. So it's like a note, either a black or white note, with sort of 2 little auxiliary lines extending in both directions. So in some sense, there's 4 different little extensions, 2 up and 2 down. So it's somewhat consistent with this thing here, okay? So I'm not saying this is too serious, and no doubt we could consider all kinds of other things. And we should, okay? We should think carefully about a sensible system like this. But at least this is an initial foray that matches up. And so now we could, in principle, write music in this new parity notation for music. I'm Norman Wildberger. Thanks for listening.